Hi, today we're starting with a schematic capture. By the end of this episode we hope to have generated our netlists ready to move into PcbNew for the start of the next episode. Okay, so where we left off last time, we'd nearly finished this second gain stage. All we need to add is these diodes that form part of the feedback loop. Is this a 1N4148 silicon small signal switching diode. And then we're into this third gain stage here, and you can see here we've got a three-way switch between no clipping in the centre, silicon and germanium, but I think that switch is done a little weird because really, how does that, if that's an on-off on, how does that connect to that centre one? Here is my original printed from Tagboard FX with all my notes on it. I used to love working from Tagboard. Now I can't stand not working from a schematic. It's painful trying to work out what the circuit's doing on stripboard. So this switch here is this switch here. When the switch is in the center position, it's open. There is no connection between this cap here, 470N. That's wrong as well, because that's got that down as a 470N and that should be a 47N. That's quite interesting. There you go. Don't believe everything you see on Tagboard FX. The way they've got this switch wired is in the centre there is no connection here on the one I've built. Why do they show it with a connection there? Very, very odd. We have a decision to make. I think we do it as the one I've built, but I'm going to include the extra pins that will let us put in whatever circuit we want in between those 2 points anyway. So I'm going to ignore actually how this schematic is. I'm going to follow the one I built before, the one I did last time. There we go. The way this is wired, no, that doesn't work. That's a two-way switch. They've got three connections to it. I'm going to make a copy of this part and give it the name D9E, so in the future I can just select that part and I know it will use this footprint which fits the part nicely. So to create a new part from an old part, we can go duplicate symbol and it will create a copy of it. If you double click on that, it will take you to this footprint and it's got this name with a -0 after it. If we hover over the text and press E, the text, we can now give this the name D9E. And that's it. It's now saved as D9E. We just need to save all libraries. Done. The footprint now is still the same as the one that was previously selected, which is that one. So now we have one that's forward biased and two that are reverse biased. And then we have the tone section. So again, like we're gonna do on these, eventually we'll add in a couple of pins here so we can bypass this whole section or insert something else here like a 3-band EQ. You could do a Marshall stone tack, we could do a Dumble tone stack. There's lots of choices of tone stack that we could put in here, so I'm gonna lay this one out. We'll have it on the PCB, but we'll also have the option of just leaving all these components off the board, and we'll put a connection in here, and we can put our own circuit on a daughter board if we wish. Okay, so when you're hovering over a component, if you want to flip it around the x-axis, you can press X, or the y-axis, you can press Y. So we got another 47N. Now I wonder, tone 2. Tone 2 is connected to another 470N. That's really weird. So the other two, they're all down as 470Ns. All. That is weird. Because that's quite impressive that they've cocked that up so many times on here. It's not on here. This schematic, I guess, is correct. It's this schematic here where they put the wrong values in, and this is the one I built. So I like the sound of it. So we'll see whether the result of a mistake was a happy one. And then this goes to our output. Now our output just connects to this label here, so we can just copy that and paste that there. Okay, let's save that. So this is essentially our finished schematic. We'll go through and check every part, but I'm going to do that when we give it these numbers, because I'm going to give it the same numbers as this schematic here. However, if you're working from your own schematic, you're probably not going to want to go through and name every part individually. So what we can do now is go to here, annotate schematic symbols. And this will put in, so where you've got resistor question mark or Q question mark, it will add in a number. It will go sequentially, and that way you can identify it on the PCB. You can reference it to the schematic. You have a choice of whether you do it by X and then Y position or by Y position. I tend to prefer by X position. You can choose to reset the existing annotation or keep what you've already done. So if we go annotate, this is now put in numbers R1, R2, R3. Now I name electrolytic caps EC and normal caps C. Because then when you do your bill of materials, it separates them out very nicely. It's much easier when you're building a circuit to do it in that order, and it's much easier when you're shopping for components to separate them out. Okay, so that's named our resistors. What I'm going to do now is go through and check all of the values and make sure they're correct. But also I'm just going to check the annotations and make sure they are the same as these. Check. Error, pin connected to some pins but not to others. Okay, well that's fine, that doesn't matter because we're just testing something. And pin connected to, that's fine because it connects to ground, and ground connects to others, so that's fine. That's, I don't know why it throws up errors on those kinds of things, because it's not an error, but hey ho. Okay, so the next thing we need to do, we've finished our schematic, we've checked through it, and we have annotated it, so we've given all our parts numbers. The next step is CV PCB, and this is what associates footprints to each schematic symbol for this specific board. These warnings here, it's just saying it's found multiple footprints for each part, so it can't decide which one to pick, but that's fine. Looking at the one I built, there isn't a single 47N capacitor, they are all 470Ns. So I'm going to make sure that the part I put in for the 47Ns can also fit the 470Ns. Sometimes it's great when we do this to reference the part, and I will use my footprint sorter to make sure I'm getting the right footprint for the parts I actually have in stock. If you click this little symbol here, view selected, it will bring up the part we've selected. So at the moment this, okay, these are wrong. Okay, so it's selected SMD caps, and I'm not going to use any SMD caps on this because they're quite difficult to find in some values. So I'm going to go with film caps. And there's a few different options here. So 470N, let's see what we have in stock. So anything that's 470N or 47N in this case will be box medium. And you just double click and it's now assigned that footprint to that part, C4. So most of these will be box medium. So 22N, 2N will be box small. I know 10N will be box small. 470p, let's go with that footprint because that will fit a box if we want to. But it's better for the ceramic caps. Another 47. Okay, diodes. Yep, that is the correct part for them, that's fine. These we've already assigned, so that should be fine. Pots. Okay, we have a choice of pots. We've got alpha 9mm or we have these alpha, I think they're 16mm ones. Just for ease, I think I'm going to go with these ones because I know I've got them in stock. The other ones I don't know if I do. So I'll leave that as is. And on the footprint I've specified this drill hole. And it just means you can use the PCB as a drilling template for doing your enclosures. Electrolytic caps, we've only got 2 on the board. Is that alright? You know what? The one I've built has power filtering, so you know what? I'm going to add that in. I should have saved what I did. That was a mistake. I should have saved it because then what I would have done already would have been saved. The original I built also has just a smoothing capacitor. I like to do a smaller film cap along with it, maybe 100p or 100N. And if I do it this way, it saves me routing any more traces around. We'll just annotate again, keep existing, annotates, made them EC3 and C1. That makes sense. Okay, so let's make that 100M. Go back into here, and unfortunately we've got to start again because I cocked up, so it won't take me long now, I don't have to explain it. 100M will be. The schematic automatically will go to the part that I've selected here. Helps you reference which part you're actually looking at if you can't quite remember. Will be box mid, box mid. Electrolytic capacitors. So these ones where size can matter quite a bit. If you spec it too small, the pins will fit in, but you'll end up with a very crowded board. That's my standard header board connect, so that's correct. That's correct. Pins square. Yep, that's fine. Okay, BC550s, these have nothing assigned at the moment. So, transistors. Got some of the more like weird germaniums and Russian stuff. What I'm going to do, there'll be this footprint, but what I'm going to do when we get to the PCB stage is I'm going to copy the part and also put in a SOT23 transistor footprint as well. So you'll have the choice of doing SMD transistors as well as 3-hole ones. But for now I'm just going to specify them as those ones. Okay, and resistors. for some reason it's specified them as the really small ones. I think we'll use 0805 ones pretty much across the board. Any I don't have, I'll have to do some shopping for. Okay, and then we go to switches, and that's the M9040P is the standard toggle switch that I'll use. And our last two pots, so that's correct. Apply, save and continue, save schematic. Okay, so that's as simple as that. We've now assigned footprints to all of these parts. So the next stage is to generate a netlist. Generate netlist, one I made earlier, just delete it, Pharaoh move, done. That is now everything that we need to do on the schematic before we move to the PcbNew. So you could close this down and open PcbNew, or you can press this button here and it opens up PcbNew. So this will be the end of this episode. So the next lesson we'll go through importing our netlist into PcbNew. We'll do board outlines and we'll try and get our components laid out how we want the board to look in real life. We might start doing some connections, but I'm going to concentrate on just getting all the components laid out, because there's quite a lot of things that you should start to consider at the very least at that stage before you start actually putting in wires. Getting the components in the right places on the PCB is the battle. If they're in the right place, routing all your signals will be fine. If they're not in the right place, it's going to be a pig. So that should be the focus of next lesson. I hope you enjoyed this. Thank you very much. See you next time.